Have you ever held a sponge under a faucet before? Slowly it drips. The sponge begins to absorb the water droplets. A steady stream starts to it. The sponge keeps absorbing the water. You crank the faucet wide open. The water begins to run off the sponge and down the drain. That sponge in your kitchen? China spent $12 billion building 30 of them. They built them out of concrete, wetlands, and rooftops covered in grass. They call these new cities sponge cities. However, they're flooding anyway, despite all the work. Here's the part nobody puts in the brochures, though. 30 pilot cities, more than a decade of construction, 19 of them still flood. The world's biggest, most expensive, most ambitious flood control experiment is half working. Sadly, the man who invented it just died in a plane crash visiting the world's largest natural sponge. We need to talk about this. For 4,000 years, engineers had one job with rainwater: get rid of it. Romans built aqueducts, Persians dug canals, medieval cities cut ditches. Every modern city pipes it underground and dumps it into the river. Every method involves moving the water. Not this one, though. Not the one China is building. In 1998, a Chinese landscape architect named Kongjian Yu walked into a meeting and said, "What if we kept the sponge cities?" Everybody in the boardroom looked at him like he was insane. He was not insane, though. He was ambitious. Principle 01. He wanted to stop fighting water. Yu grew up in a village in southern China where two rivers met at his front door. When he was a kid, he fell in the water during a flood and almost drowned. This moment had a big impact on his life after all. He should have drowned. However, the river was so full of plants and reeds, acting as a natural sponge. The vegetation caught him. It saved his life. That moment became a career for Yu. He decided that every city in China was being built wrong. Concrete pushes water away. Plants hold it. His idea, called negative planning, said, don't ask, where will we build? You must first ask, where must we leave room for water? Principle 02. A sponge city is not just one thing, though. It's three scales strategically put together. It consists of macro, whole river basins, restored wetlands, floodplain forests, things you fly over and don't even see as engineering. Meso, neighborhood level zoning, where the parks go, where the lakes go, where you're not allowed to pour concrete. Micro, your block, the rain garden between the sidewalk and the street, the green roof on the apartment building, the permeable pavement in the parking lot that lets water sink in instead of running off. 3 different scales, all with the same job: catch the rain before it becomes a flood. Principle 03. There are just 6 tools in the Sponge City toolbox. Just 6. That's it. Rain gardens, araus, sunken patches of dirt that drink runoff. Bioswales are long ditches with plants that filter water as it flows. Green roofs are apartment buildings with grass and sedum on top instead of tar. Permeable pavement are sidewalks and parking lots water can soak through. Constructed wetlands are fake marshes built into city parks. And retention basins are big shallow holes that fill up during a storm and slowly drain over days. Each tool catches a tiny amount of rainwater. Put them on every roof, every street, every parking lot. The city stops being a giant impermeable area and starts being an actual sponge absorbing the water. Principle 04. China set one target: 70% of rainfall has to be absorbed on-site, not piped away, not pumped into rivers, absorbed by the city itself. That's the number every sponge city in China is graded against. 70% is the line between a sponge and a sieve. Principle 05. Here's the part civil engineers don't put in the TED Talks, though. The one catch to the program: you cannot design a sponge city until you can actually see the city. I don't mean to just look at it, I mean see. You have to see every contour, every ridge, every place where water will collect when the storm hits, down to centimeters. That process used to take years and years to finish up. Surveyors with tripods walking up cliffs, cutting line through the jungle with machetes. People died doing this work. Then drones happened. You strap a laser scanner to a drone. The drone flies a grid pattern over the area. It shoots 150,000 pulses of laser light every second straight down at the earth. Some pulses bounce off the leaves. Some sneak through the gaps and hit the actual ground underneath. Software is able to throw away the leaves and keep the ground. What you get then is called a bare earth point cloud, a perfect 3D map of the dirt under the forest, accurate down to the centimeter. Impressive. In Fiji, though, one company mapped a 2,500-acre gold mine site this way, in days, not months. 5.5 billion data points. That's how you find every place a city is going to flood, before you build the sponge. Principle 06. Now here's where the dream meets the math, though. A sponge city is designed for what hydrologists call a one-year storm, the kind of rain that hits any city every 12 months or so. The sponge absorbs all that water. No problems. However, something else happens when the storm is bigger, though. In 2020, Wuhan, China's flagship sponge city, got hit by a record monsoon. It flooded. In 2021, Henan, China got nearly a year's worth of rain in 3 days. People died during the storm, though. The sponge cities helped. They reduced peak flow. They delayed the flood by hours, which in turn did give people the chance to evacuate the city safely. However, they did not stop the flood. Not at all. Nothing on Earth is capable of absorbing that massive amount of water. There's a quiet revolution in this story most people miss, though. The people who used to map this terrain, the surveyors, they were the most at-risk workers in civil engineering at the time. They surveyed cliffs, mine shafts, dense jungles, unstable ground. They endured snake bites, the summer heat, the winter cold, even falls, introduced drones with LiDAR technology, and they didn't just make the job faster, they made it survivable for the surveyors. Then there's Yu himself. In September of 2025, Kongjian Yu got on a small plane in Brazil. He was flying over the Pantanal, or the largest natural wetland on Earth. He was making a documentary about it, about how nature itself is a sponge, about how cities should learn from this technique. The plane went down. Yu didn't make it. 4 other people died with him. 2 filmmakers and a pilot. The man who spent 30 years convincing the world to build artificial sponges. Gone just like that. Yu died visiting the biggest real sponge in the world. That's not a metaphor we made up. That's what happened. So what do we do with all this information? Sponge cities are real. They reduce flooding. They clean water. They cool the streets in summer. They're cheaper than the concrete alternative we are currently using. They are also not enough. Not for the storms that are coming. The honest answer is, though, sponge cities are part of the solution. They are just not the whole solution. You still need pipes. You still need pumps. You still need somewhere for the water to go when the sponge is full. That raises a much weirder question, though. What if you stopped trying to absorb the flood, and instead, we just built a city above it? This would include floating neighborhoods, stilted infrastructure, whole districts of a city that rise when the water does. That's not science fiction. That is what's being built right now in the Netherlands, in the Maldives, in Lagos. If this video taught you something, hit the like button. It tells YouTube to show this stuff to other people. If you really enjoyed it after you liked the video, a hype becomes available. Send me a hype as well for more content like this. Subscribe if you want more educational content in an easy to understand way. Drop a comment with your city's worst drainage story. I read them. We'll see you in the next video.